this program in various levels, whether they want the technologies to be taken up in form of TOT, or they want specific technologies to be developed through the program as a collaborative partner. They can come and join us for the entire value chain or part of the value chain of additive manufacturing, material, machine, FAM, or the 3D printed products.
Good afternoon, and it's a pleasure to connect with you, Dr. Saka. If you can actually elaborate, what was the idea behind NCAM, sir, and also something more about NCAM, and also about CMAT, and also the other institutions that we have been able to set up as Ministry of Electronics and Information Technology to also look at encouraging a lot of indigenization in the country. That's a great initiative, sir. Your inputs on this, sir.
Okay, thank you for the opportunity. Ministry of Electronics and IT has been promoting additive manufacturing for last couple of years. In 2022, we released a national strategy for additive manufacturing, where the purpose was to increase the market share of additive manufacturing globally. Initially, we have targeted a $1 billion market, under which we have taken initiatives to increase the deployment of the additive manufacturing in various sectors. NCAM is part of that deployment sector and is leading the structure for deployment of additive manufacturing in India. We have also other centers where we are developing technologies for which will be affordable to India. The technologies in the various sectors such as electronics, optoelectronics, optical computing chips, medical device sector, agri and food processing, renewable energy, and so on. We are also looking to initiate technology development for Indian manufacturing in other sectors such as shoe manufacturing or mud cooler manufacturing, construction, and so on. So the purpose of this is to increase the digital manufacturing sector in India, transforming India from lower industrial revolutions to Industry 5.0. This is the primary target of additive manufacturing strategy by MATE.
I am Dr. Sunit Rane from Center for Materials for Electronics Technology, working as a scientist. Couple of years ago, we have initiated Center of Excellence on Additive Manufacturing Technology, which is basically for the development of materials for electronics applications. The main domain is electronics. So under this COE, we are working on different materials required for electronics like metal, ceramics, semiconductors, and filaments, which is cheapest technology where we can focus for the electronics components. CMAT is basically working in the area of electronic materials since past 30 years and being an expertise in the materials area, we have initiated this additive manufacturing technology, and for the development of materials like powder materials, filaments, and inks, which is the domain of CMAT Pune. In the additive manufacturing, we are intent to develop the different kinds of materials, and there is a intention to develop the printers, compatible printers with the supporting of the industry. So CMAT is developing materials, and the compatible printers will be developed by the partner industries which are currently associated with the COE are Intech Additive Private Limited, then SPL and Pravartya, as well as the JGR Technology Mumbai.
CMAT, we are actually Center for Materials for Electronics Technology. We are an autonomous body under the Ministry of Electronics and Information Technology. So basically we can call us as a scientific society reporting to MIT. So we work basically on materials that is required for the electronic applications. We are actually working in the area of packaging that's based on LTCC for the last 15 years. So we have set up a fabrication facility for packaging of even the semiconductor chips, or for MEMS devices, for sensors, for all this packaging this technology can be used. So we do have a full fab for this conventional method of fabricating of LTCC packaging, and now we are trying to adopt, because the potential of these technology is immense. That is why, but because this technology becomes very costly, and that is why the small scale manufacturers or entrepreneurs are not able to set up this fabrication. And that is how we are now thinking of adopting AM technology using digital light projection, and we are trying to set up the 3D printing process for LTCC based packaging. So that is definitely going to bring down the cost of the packaging as well as time that is required for making these packages. It's a big difference in cost will be there, and it will bring a revolutionization into the technology itself. DLP is actually the digital light projection technology. There what happens is, like, you are able to project the light, and typical like a lithography process we are able to build up the product, in this case a package, layer by layer in a much smaller time. That is what we are trying to do, and that will bring down the cost also, and will help us, because the semiconductor chip technology itself has improved a lot. There are a lot of renovations that is coming in, and the technology is improved. But as far as packaging is concerned, people are still stuck up. There's a lot to improve on the packaging aspect of it. So this technology will help us to come out with customized design, and so we can develop newer products that will help us to come with new products even in the device scale level also, and at a cheaper cost. So that's a big advantage that we'll have for the nation.
Started with, I should congratulate Ministry of IT and CMET for doing such a nice initiative in 3D printing, and the LCNR needs some of the day by day what happened, the complex designs are coming in component. With the insertion of the new technology like 5G, 6G, strategic satellite communication and defense electronics, the need of the augmented realities are growing day by day. We are estimating that around 2026 we will be around 300 billion manufacturing and 500 billion manufacturing by 2030, which implies that we require by 2030 around 5 million direct employment, and that's how, if we see, we require around 30 to 50,000 professional in the 3D printing on research, new technologies, and that is one of the key areas we should focus on, bringing the manpower so that the technologies like semiconductor, the complex component like SMD, the complex PCBs of multiple layers can be manufactured by the Indian professionals. Now you must be knowing, if one professional come, indirect there is 3 employment also generated. So this is a huge opportunity for the employment generation also. Thank you very much.